Hello everyone, Multipro here. Today we're going to solve equations when we have a variable on each side of the equal sign. And if you want to learn more about this topic, please subscribe. Please subscribe right now. This is going to cover how we solve equations with the variable on each side, and then also we're going to solve equations involving grouping symbols. So I'm going to pause right now to give you time to click that subscribe button. Alright, let's dive on in and look at our first example. Example 1. Alright, we have minus 2 plus 10y is equal to 8y minus 1. Okay? So here we have y on each side of the equation. How do we handle this? We're going to handle it just like it was a number. Okay? So, sorry for the snoring, but Grandma's asleep over here. If you hear that. So, what we're going to do is first, let's handle the numbers. Okay? And the way I'd like to do this is, since this y here is bigger than this y, I'd like to get the y's over here, and then therefore I'll just put the numbers over here. In my head, that makes things a little bit easier, but you can choose to do it however you may. Alright, so let's subtract 8y from each side. So minus 2, actually, let's go one step at a time here. Let's get the numbers by themselves. So let's add 2 to each side. So 10y is equal to 8y plus 1. Okay? Now, what we're going to do, and I apologize if you hear Grandma snoring. Alright, so we're going to subtract 8y from each side. And that's going to be 2y is equal to 1. Alright, now let's divide each side by 2. So then y is equal to 1/2. Alright, let's plug in this for y to see if this makes sense. And I'm sorry if you hear Grandma snoring. Alright, so minus 2 plus 10 times 1/2 is equal to 8 times 1/2 minus 1. Alright, so minus 2 plus 5 is equal to 4 minus 1. 3 is equal to 3. Jackpot! We got it! Great job! Alright, let's look at a second example here. Example 2. Let's say that we have 2z plus 5 is equal to 5 times z minus 7 minus 3z. Whoa, now we got 1z on the left and 2z's on the right. And look here, we get to use our distributive property, and that's great. Okay, so let's go ahead and simplify this a little bit. Let's say that we have 2z plus 5, which is, let's go ahead and do this distributive property. It's 35 minus 3z. Alright, let's get these z's on the right all subtracted because we got a minus sign here. So we got 2z minus 35. Alright, now let's go ahead and divide each side by 2z. Well, let's go ahead and subtract 5. Subtract 5. So 2z is equal to 2z minus 40. Alright, now let's subtract 2z from each side. And sorry if you hear Grandma snoring here. Alright, so then we get 0 is equal to minus 40. Well, that didn't work out. 0 does not equal minus 40. So in this case, this was a false statement. This was false. So this is not an identity. What is an identity? Let's talk about that next. Identity. Is this like who you are? Well, that means that also. But this is math. We're going to talk about math today. An equation that is true for every, and I apologize if you hear the snoring from Grandma, for every value of the variable. Okay, so whenever you plug in something, solve an equation for a variable, it is always true for every value there. Okay, so in this case, that last example, we did not have an identity. All right, let's talk about some steps. Okay, is this like when you climb a Great Pyramid? No, it's not quite like those kind of steps, but it's similar. It gets you to a destination. Steps for solving no, it's not solving equations. Oh man, Grandma snoring. Sorry if you hear that. All right, so the first step is we want to use the distributive property. And then the cat scratching. All right, to remove the grouping symbols. All right, step 2, we want to simplify the expressions on each side of the equal sign. I'm sorry, I hear Grandma snoring. So, all right, that's step 2. We want to simplify. We'll make it easier, right? Step 3. Use the addition and or subtraction, depending on the problem, properties of equality to get the variables on one side of the equal sign. And the numbers without variables on the other side of the equal sign. Okay? And that's what we did above, right? I know it was a very lengthy explanation, but what we did is we used addition or subtraction to get the variables on one side of the equal sign and the numbers on the other side. And I usually started with the numbers because numbers are easier for us at this point than letters, right? So we want to get all the numbers on one side, and then let's work on getting the variables on one side. Now, when we looked at it, we tried making it easier for ourselves. Rather than deal with negative signs, we wanted to deal with positive signs as much as possible. So we made the variable, we subtracted the smaller, from the larger variable the smaller variable to make that work. So if you want to pause and rewind, you can go back up and see what we did there. Now there's a fourth step also. Once we do this, we have to simplify the expression. And sorry if you hear Grandma snoring. Each side of the equal sign. Okay. And then the last step, we have to use the multiplication or division property sorry if you hear that, equality, to solve. Okay, now that's what we did as our final step there. And usually we had a number multiplied up against a variable, so then we divided each side by that number to get the variable completely by itself. Now when you do this step 5, there's two results here that we want to talk about. If the solution results, about to say something not good, results in a false statement. We had that happen, right? We had 1 was equal to minus 40, and that was not true. There is no solution, sorry. It's just funny sounds of the equation. It's hard to keep straight here. Okay. And then if the solution results in an identity, the solution, oh my goodness, is all numbers. Okay. Oh my goodness. Alright, now let's look at a problem here. And this will be our last problem of the day. Alright, so the rectangle and square results in sorry, I was looking at my notes and I copied down the wrong sentence here. Okay, I'm getting distracted by the snoring. Have the same yeah, I wish our place was a little bit bigger. I could get away from this wouldn't be so distracting. Alright, same perimeter. Okay. Wow. Okay, so we want to find A. Okay, A is what we're looking for. Alright, let me draw these. So here we have a rectangle. And here we have a square. Okay. And we got 3A plus 1 is the length of this side. And this side is A. And this is 3A. So we know all sides of the rectangle are 3A. I mean the square is 3A. Right? And we know that this is 3A plus 1 because it's a rectangle. Okay? So let's try to find out the perimeter of the rectangle. Okay, and then we'll try to find out the perimeter of the square. So the perimeter of the rectangle is 2 times this 3A plus 1 plus 2 times A. Okay? And perimeter 2, oh my goodness, is 4 times 3A. Okay? And we want to set P1 equal to P2. Alright. So let's go ahead and, since they have the same perimeter, we know that P1 is equal to P2. I'm getting so distracted. Alright, so we got 2 times 3A plus 1 plus 2A is equal to 4 times 3A. Alright, let's go ahead and use our properties here and solve for A. 6A plus 2 plus 2A is equal to 12A. Alright, and then we got 8A plus 2 is equal to 12A. Okay. Let's make sure I'm solving this correctly. Okay, so we'll subtract 8a from each side. So 2 is equal to 4a. Let's divide by 4. So we find that 2/4 is equal to a, and we know that that equals 1/2. 2 over 4 is 1/2. Alright, so we found a. A is 1/2. Okay, so these are 1/2. This is equal to 3/2. And this is equal to 3/2 plus 1/2, which is 5/2, or 2.5. So what is the perimeter? Let's plug it into probably the simplest equation we got. This one is a little bit easier than this one, right? So let's say P2 is equal to 4 times 3 times 1/2 is equal to 12 times 1/2 is equal to 6. So the perimeter is 6. Alright, great job. That's all we have for today, and I hope it was a little bit entertaining for you guys. I will see you all next time. Please hit that subscribe and like. See you next time.